Welcome to the Crazy Hat Chemist. So here we go. Equilibrium and reaction rates. Today is the 8th video in this series, and here we go. Bam! So applied equilibrium shifts. Hopefully you can see this equation right here on your screen. You have Fe3+, which is an iron ion in solution, and it is actually yellow. And then there's thiocyanate, and that is SCN, that's a polyatomic ion, and that's a -1, and that is colorless in solution. And then on the product side, you have the iron thiocyanate complex ion, and that is red in color. This is an equilibrium reaction here. Hopefully you can see that with those two arrows. So the first thing that we're going to do is we're going to write out the equilibrium constant expression. That is the KEQ. So I want you to pause the video. I want you to write the equilibrium constant expression and then unpause it. So here we go. Bam! So it's the KEQ. Remember, it's products over reactants with the stoichiometric coefficients as exponents. There are no solids, there are no liquids in here, but there are aqueous solutions, so everything is included. The stoichiometric coefficients are 1, so that makes this KEQ expression very simple to write out, hopefully. Okay, you do not have to include the colors. Okay, so this is what we're going to do. We're going to say which way is the equilibrium going to shift if you increase the iron ion. So what we're going to do is look at this equilibrium equation that we have here, and then we're going to put an arrow either up or down next to it and then shift it either right or left. So as we increase the iron ion concentration, which way will it shift? Well, we want to get rid of the iron because now we have too much iron. So the way to get rid of the iron is combining the iron and the thiocyanate to form iron thiocyanate complex. So we're going to shift it to the right. All right, let's try another one. We're going to increase the thiocyanate concentration. So if we increase thiocyanate on ion concentration, we need to also get rid of it. How do we get rid of the thiocyanate? By combining the iron, the thiocyanate, and forming the product of iron thiocyanate. Okay, let's try another one. We're going to increase the iron thiocyanate complex ion. So if we increase this, how we get rid of it, making less of it, is breaking this apart and making the reactants. So hopefully that makes sense for you. Notice it's up and away, up and away. Okay, now let's try another one. Decrease the iron concentration. So now we're going to put an arrow where the iron is, but decreasing it. Okay, now we don't have enough, and now we need to make more. How do we make more? We need to make more iron, and that's shifting it to the left. Hopefully that works for you. We're going to decrease the thiocyanate ion concentration. So an arrow with that, decreasing it, and we need to make more of that, and that shifts it also to the left. Okay, and we're going to decrease the iron thiocyanate complex ion. So decreasing it, we're shifting, and we don't have enough, we need to make more, so it's shifting it to the right. I want you to pay particular attention to the pattern of which those arrows are and what side they are on the double-headed arrow there. Okay, now we're going to try a one that's going to really throw you through a little loop here. So here we go. We're going to add silver ion concentration here. So do you see silver ion in this equilibrium? The answer is no, I don't see it. So if you don't see it, then the first thought is, well, it doesn't affect it. But then you need to ask yourself, what will it interact with if it does interact with anything? And so silver is a 1+ cation. Now, cations get together with anions. So there's only one thing that the silver could react with, and that is the thiocyanate. And here's the reaction between silver and thiocyanate, right here. Okay, now I want you to look at this equilibrium reaction, and I want you to look at the shift of those arrows. So that is that silver and thiocyanate form a solid silver thiocyanate precipitate. That means it's going to remove the silver ion and the thiocyanate ion. So if I add silver to that top reaction with the iron, the thiocyanate, and the iron thiocyanate complex ion, it will actually decrease the thiocyanate concentration, and that will cause an equilibrium shift to the left. Okay, we're going to do one more here. We're going to add neon. Now, neon is a noble gas. Do you see a gas in this equation at all? Okay, so it deals with partial pressures and gases. So neon does not interact with iron, it does not interact with thiocyanate, and it doesn't interact with the iron thiocyanate complex ion. So there's going to be no change on this. And I'm going to give you a better explanation of this when you watch the next video in this series about gases that do not react with other things within the equilibrium constant expression. Okay? And that was the 8th video in the Crazy Hat Chemist unit on equilibrium and reaction rates. Hey, if you like that, give me a thumbs up.